Hey everybody, it's Mr. Carr again. Today we're going to be looking at 8.4 using basic trig identities to find trig ratios. This one's going to be a quick one. There's only three examples to go over, and everything's pretty much the same idea. So we want to find the exact value of cosine of theta if the sine of theta is equal to 1/4 and 90 degrees is in between, or I should say theta is in between 90 and 180. So what's happening here is that you've actually done something similar when we created right triangles, but now we're going to put them in specific quadrants. And because of this restriction here, we're in quadrant number 2. Because if we look at that 90 less than theta less than 180, that puts me over here because that's 90 and that's 180. So I can kind of use that to help model the fact that sine is, there we go, 1/4. So when we do that, we're in the second quadrant. Remember, this is sine, which is opposite over hypotenuse. So what I want to do is I want to label my triangle here with 1 and 4. So that's the opposite side to my reference angle. 1 and, sorry, the opposite side to theta there is 1. The hypotenuse is 4. So the next thing I do is I need to find this missing side length. So I'm going to call it x. So we got x squared plus 1 squared is equal to 4 squared. That's plus 1 is equal to 16. X squared is equal to 15. And then I square root. So x is equal to a plus or minus root 15. But in this problem, I'm not going to do the plus or minus because in the direction I'm going, we're only going to the left. So that's why I'm going to use that negative root 15 here. Don't know how that came out. Negative root 15. All right. And again, so I stuck with the negative version because it went to the left of the graph. So all that work, I'm going to start with now the cosine of theta. Well, cosine is going to be adjacent over over hypotenuse. And that's it for that one. So find the exact value of the cosecant if cotangent theta is negative 3/5. Okay, it might help if you think about the reciprocal instead of the negative 3/5 here. So the reciprocal is negative 5/3. This is telling me it's in quadrant number 4. Okay, so if I model that real quick, we've got this is tangent, so that is going to be the same as opposite over adjacent. Okay, so if I go build a triangle like this, here's my reference angle theta. This is negative 5 is opposite that because I'm going to go down. I'll call that a negative 5. And then 3 is right here. So from there, I can do just like last time. I'm going to start with Pythagorean theorem. So we got x squared is equal to 3 squared plus a negative 5 squared. So that's going to come out to 9 and 25, which is 34. And then I square root that. Excuse me. So I get it. Sorry about that. Okay. So that is not going to be a negative. It just stays like that. So when we look at cosecant, it's helpful to first look at sine, the sine of theta here, when equal to the opposite of hypotenuse. So it's a negative 5 over the square root of 34. But because we're dealing with a reciprocal, I'm just going to take the cosecant of theta equal to the square root of 34 over negative 5. Okay? So again, it's analyzing these reciprocals. It's helpful to remember what the original one looks like. Fix that a little bit. Okay? So being able to model that or just kind of understand where it is in terms of the quadrants. All right, find the exact value of secant theta if sine theta is equal to negative 2/7, and this is our limitation. So this is going to be quadrant number 3 when it's in between 180 and 270. So we're going to model that on here. So negative 2/7, that is again opposite over hypotenuse. So that's going to look something like that. Negative 2 and then 7. So this will be my reference angle theta. So first things first, let's find this missing side length here, x. So it'll be x squared plus a negative 2 squared is equal to 7 squared. Okay, so that'll turn into 4 and 49. I subtract that over. So x squared equals 45, and then I square root those. And if you want to, you can leave it as, it'll definitely be negative 3 root 5. Okay, so that's my x value. That means I want to find secant. Well, secant is the reciprocal of cosine. So if I write that down real quick, cosine is going to be adjacent, so negative 3 root 5 over hypotenuse, which is 7. So I'm going to flip that for secant. Secant theta is equal to a negative 7 over 3 root 5. So we're going to multiply this by root 5 and root 5. Okay, so secant theta is going to be equal to a negative 7 root 5 over root 5 times root 5 is positive 5. 5 times 3 is 15. And that's it, because we wanted to be in this quadrant here, and only tangent is positive there. So that's all we have here. Okay, and that is actually it for the unit as well. So make sure that for this specific lesson, I would highly, highly suggest drawing out the triangle diagram. Hopefully that helps keep your X's and Y's in order for when you have to translate that into the formula over on that side. All right, but that's it for today then. Take care, everybody.